Good day, students. My name is Deborah and in this video we're going to be looking at urban climate, and I'm here with Smart Prep, and we'll get right into the video. Do not forget to like, share, comment, and do all the things that need to be done. Alright, let's get into it. So in this video we'll look at the urban climate. We'll compare it with rural climate, which we did in the previous video if you haven't watched that. We'll look at urban heat islands, and we'll look at pollution domes, and then we'll look at strategies to reduce the effect of urban climates. Alright, but we'll begin with some definitions first. Alright, so with the definitions, the first term is the acid rain, which is a form of precipitation that is acidic. This is because of the water droplets that dissolve the gaseous pollution molecules. So as the droplets are there, the droplets are dissolving the pollution itself. And we have albedo, which is the amount of incoming solar radiation or insolation that is reflected by the Earth's surface. So this is a reflection. And then condensation nuclei is the particles of dust, smoke, or salt in which water vapor sticks and condense, or we call this the hygroscopic nuclei as well. And more specifically, hygroscopic nuclei is the small solid particles in the atmosphere on which the water vapor condenses to form tiny water droplets, and then this water droplets merge to form raindrops, which results in cloud formation. So this is sort of linked together. That could then, if you link it to the definition of acid rain, that could exist as a result as well. And then we have isotherms, which is a line on a map that connects points of equal temperature. And lastly, we have the plum, which is smoke, dust, fire, or water. That is a large quantity of it that rises into the air in a column. Right. So now we will look at pollutants, which are dome-shaped concentration of polluted air that is above the center of a city or industrial area. And we have pollution domes, which is a massive polluted air that is temporarily trapped over a city or industrial area. We have smog, which is a thick ground-level fog. So smog, we've talked about this in the rural video as well. A thick ground-level fog caused when water droplets become polluted with chemicals and gases found in the atmosphere due to pollution. So it's a mixture of smoke and fog, and I hope you begin to see the link between all the terms. And urban climate is a climatic condition specific to large urban areas, of course. And then urban heat island is a temperature over the city, which is warmer than the surrounding rural area, and we'll talk more about this concept later on. Alright, now we'll contrast urban climate versus rural climate. Again, if you haven't watched the previous video, please go watch it. We'll look at 4 things. We'll look at temperature, pollution, cloud cover, and precipitation. In terms of temperature, in the urban climate, it's warmer due to the lack of vegetation and transpiration. There's more artificial heating, air conditioning, vehicle emissions, as you can imagine. There's more artificial surfaces as well, tars and concrete that absorbs heat, so it's warmer. There's more dust and pollution from factories and all that prevents the heat from escaping. Versus in the rural climate, it's generally cooler because there's less artificial surfaces and more vegetation cover. And this shouldn't be too hard to understand because this should be things we observe in such locations, right? And then in terms of pollution, we have more pollution and dust due to industrial activities, combustion processes, and traffic in urban climates as opposed to rural, where there's less pollution and less dust particles. Cloud cover, we see that there are more clouds that form as there are more dust and pollution particles as opposed to in rural, where there's fewer clouds because of less hygroscopic nuclei. You can remind yourself what that is in the previous. You can skip back a bit. In precipitation, there's more rain and hail in the urban climate because of the presence of more hygroscopic nuclei, which is found in the atmosphere, and the strong updrafts of air. And then we also have a warmer temperature, which causes more evaporation, as opposed to rural, where there is less rain and hail because of lower temperatures and less condensation. Okay, now in terms of relative humidity, there are lower evaporation rates of humidity in the urban climate because of less vegetation cover and natural resources. There's less surface water to evaporate. There's warmer air which can hold more moisture. Versus in rural climate, there's higher relative humidity because of water retention that exists in the soil and in the vegetation itself. And then in terms of wind speed, we have less wind speed in urban climate because of buildings that create friction, and we have the wind breaks. We also have greater turbulence, right, because the wind is channeled between the buildings, as opposed to rural climate where the wind speed is higher. The turbulence is less due to the open space, and then air pressure is lower because of warmer temperatures in the urban climate, and it's therefore higher because of the cooler temperature in rural climate. And then lastly, in terms of fog and visibility, there's more fog and poor visibility due to more hygroscopic nuclear and condensation nuclei. The fog is a problem in winter when temperature inversions trap pollutants close to the surface of the earth, and then in rural there's obviously less fogs, which results in better visibility. Alright, so I hope that helps you in terms of comparing and contrasting, and this is again more logically sound because you can think about the difference between urban place and rural area. Okay, now we move on to urban heat islands, and if you can see, there's a graph here, and it shows you the difference at night and versus the day, right? So depending on where the factory or what the surface is. So it says here the temperature over the city is warmer than the surrounding rural areas. So towards the edge would be more rural areas. So you can see the thicker lines represent the surface temperature, and then the dotted lines represent the air temperature, right? So you can see that in the trees where there's forestation, there is a dip in the surface temperature, and then the air temperature is higher at night, right? But over the buildings and stuff, the surface temperature is higher than in the rural areas, versus even during the day it's also relatively higher. So you can just see that the trend is it's higher it's fluctuating, of course, because of what is there, but where you can see the higher buildings, that is warmer conditions, right? So this is a different way of showing it. In the exam, you may be asked how the temperatures changes as you move towards the center of the city, which is the urban heat island phenomenon. So this figure shows you how the temperatures increase the closer you get to the center, or the CBD, or the central business district. And then notice how we have the lower temperatures that downward peak in the parks and rural areas, right? So that's just the contrast that we're looking for. Okay, now we'll look at isotherms. These are therms which are a line on a map that connects points of equal temperature. So you can see from the image, the 2s are connected, the 3s are connected, the 4, and you can also see that scale that is there, where you can see that it's definitely redder in the center. And now as you go around, we have more purplish lines, so that gives you an indication of the type of temperature that you can expect, right? Okay, now we're going to contrast and compare the difference between the day and night in urban heat islands. So during the day, the heating that occurs causes the air to expand and rise. So we have a growth of the heat island vertically up, as you can see. The inversion layer is therefore elevated as well. Because of the vertical growth, the heat is less concentrated, right, because it's able to spread over a wide area. We have more of a mushroom shape, which conforms to the built up area. As you can see, like if we have a tall building in the center, quote unquote, it will rise up. The shape will also be more upwards, and then pollution is dispersed over a greater area. In contrast, at night it's cooler, so the air will become dense and sink, right? The less heat results in decreased turbulence. Vertical dimension then decreases. You see it's more closer to the surface. The inversion layer itself is also closer. The heat island is more dome shaped, and then the pollutants are more concentrated over that smaller surface area. The dome is denser and shallower. The trapped heat is more concentrated over the CBD itself. Alright. So now we'll look more in depth into why this urban islands form in the first place. So again, as we said earlier, there's more artificial surfaces, in urban areas. So we have classes, we have concrete, we have stones, brick, tarmac, and iron, which will absorb a lot more heat. There's also an increased surface area that can absorb heat, as we said. So there's more roofs and size of building. There's also artificial heat from combustion, from air conditioning, from traffic, the emissions from the vehicles, and then this is all just warm air that will therefore rise up, and that's why we have more of a pollution dome, because during the day that's when the activity is also higher, so there's just more air, more dust, more pollution that is happening in the urban heat island. So what would be the impacts of this on the environment? Like generally, because the surfaces are absorbing more heat, they can therefore radiate and give back that heat into the environment at night. There's also the glasses themselves that radiate heat. There's going to be more smog, the smoke and fog combination due to the higher temperatures as well. There's also an increase in evaporation rate, and which would cause a pollution dome. So it's just more pollution, more smoke, smog. The surfaces themselves add to the problem. And then impact on the humans, there's more discomfort. There's also heat waves and heat stress and death, even because it's just too hot. There's also reduced visibility because of the smog. There's increased cost because of a greater energy and water use that will happen inevitably during this time, right? Right, we spoke a bit about this earlier. When we talk about the urban heat islands that are formed during the night, right? So we look at pollution domes, which is when dust, soot, and chemical emissions are trapped in the warm air of a heat island, and that becomes a pollution dome. The pollutants act as hygroscopic nuclei and attract water vapor to them, and therefore fog forms. A smog is a thick ground level fog, which is caused when water droplets become polluted with chemicals and forces out, and with chemicals and gases found in the atmosphere due to pollution. Right. So urban heat islands during the day. We talked about this as well. The pollution is more dispersed. It takes a mushroom shape. Yes, we spoke about this. Pollution domes at night. So they can both be pollution domes. It's just a difference. At night we have cooler. The air is cooler, so it sinks to the bottom, or closer to the surface rather. Because also dense, there's less heat, which results in a decrease in turbulence. The vertical dimension decreases. The eventually is close to the surface. It's more dome shaped, right? Pollutants are more concentrated over the CBD area, particularly, right? Okay, so now this is an image that compares and contrasts this, and in case they ask you to draw it, you can therefore see the clockwise circulation of the warm air that is rising from the urban CBD area, and then the pollution would be the dots that exist at night. It's not that the buildings are not emitting, but it's to a lesser extent, and so the dome itself doesn't get to be vertically exaggerated, right? So now when we look at the causes of pollution domes, why they develop, we can see that it's due to emissions by vehicle exhausts, which leads to carbon monoxide and nitrogen oxide being released to atmosphere. There's also the burning of fossil fuels that occur in the urban climate, which also gives us carbon dioxide and sulfur oxide, so you must know the difference. And then the pattern of air circulation and high levels of air pollution in the city. So because the city is so concentrated, there's just more emissions, there's more burning of fossil fuels, and also the way the air moves within the city itself. So what do we do? What's the impact, rather than what do we do? But what is the impact of this pollution dome on the environment? Which means it increases cloud cover and precipitation. Acid rain will develop when the keys travel and erodes back bricks and stones rather, and then the old of the video buildings are coming off. They contribute to global warming and climate change. In contrast, for humans, smog will cause things like health problems, lung infections, asthma attacks, the like. Smog reduces visibility and causes accidents, and then lead poisoning may result from petrol fumes. Okay, so you can always think about logically what would be the impact of pollution in general on ourselves and the environment. Okay. So, what would be some of the strategies that we could do to reduce both the urban heat islands and pollution terms? Pretty standard, make the surfaces lighter, cool, color to be more reflective and less observant. You want more trees in garden, pavement, in parks, because that will increase the transpiration, which would decrease air temperature. The trees will also absorb carbon dioxide and release oxygen. The trees reduce energy costs as well as a natural cooling effect. We plant roof gardens to absorb the heat and pollution. Invest in energy saving methods such as solar panels and grass roofs. Develop sustainable public transport. Implement building restrictions on height and materials that is used in building projects. Do not use glass or reflective substances as building materials. Control the amount of pollution that is released from factories. So we want more trees, we want lighter surfaces, more lighter colors. We want roof gardens, we want energy saving strategies, public transport, change of building materials, things like that. Okay. Alright, so this is an activity. You have 1 minute to attempt it on yourself. Please make sure you do so, and then I will provide the answers. Alright. Okay. So this is some of the answers for this one. I won't really go through it. But if it's not making sense, go back to like a few minutes back, and you'll see some of the reasoning behind the answers. Right, I'll go in depth with the other questions. Right. So again, for this video, feel free to please pause it and attempt it in yourself for the slide. So despite the concept heat island, so again we have an island here. Alert: due to high temperatures, air quality is poor. Remain indoors and turn on the very aircon that uses electricity that is created by the burning of fossil fuel that contributes to the higher temperature and poor quality of air. So this is sarcasm. So define the concept heat islands. So these are areas of high temperatures in the city that are surrounded by areas of low temperature. Right? How is a heat island formed? It's because we have the built up areas or buildings that absorb and release more heat because of the building structures, the glass and metal structures that exist. We also have factories and motor vehicles, lack of open spaces, which results in the atmosphere being generally warmer than the surrounding rural areas. And then it says, name the part of the urban area A that records the highest daytime temperature, and that would be your CBD, your central business district. Then describe 2 ways in which city planners are designing urban centers to reduce the urban heat island effect. And so we'll look at those answers in the next slide. So describe 2 ways in which city planners are planning at designing urban centers. We'll look at the fact that they need more open spaces and better air circulation due to fewer buildings, right? You need more vegetation and trees to absorb the sun's heat for photosynthesis. So you don't just say they should plant more trees. You say, what would those trees do? You explain why you are giving your solution. Poor and less efficient drainage system. So standing water absorbs heat and evaporates or cools the atmosphere. We also have buildings with natural materials such as timber, mud, or thatch, which does not absorb so much heat. And then we would use less concrete or tarred surfaces, which means that less heat would be retained. So you want more on tarred roads, ironically enough. And then in the paragraph describes how strategies which can be implemented to reduce the heat islands can be effective. So establish green belt zones, decentralize certain functions, use building materials that reduce temperatures such as reflective roof paints, roof gardens, efficient public transport. So again, similar strategies. Yeah. Okay, so this is another activity. You have about 1 minute to attempt it on your own. Okay. Okay, that's time. Okay, so what is a pollution dome? That is an accumulation of dust, soot, smoke, just pollution in general, those particles over the city. So again, definition is very important as we did in the beginning. It's associated with an urban area because we have more pollution, because of combustion by the cars, industries, other activities. There is a lot of fumes, more human activity, so there's just a lot more activity in general. And then it's concentrated at night, again, as we said earlier, because the night the cold air condenses and subsidence is very strong. It's trapped closer to the air, to the ground rather. Inversion air is closer to the surface at night. There's less activity at night, so that leads to um, less heat generation to lift up the pollution domes itself. The pollution covers a smaller area, and then there's less convection of thermal currents to distribute that pollution at night. Okay, now we'll do the next question on the next slide. So now we have to explain how the pollution domes increase the maintenance costs of the built environment for people living in the city. So we can have soot that accumulates on buildings, which results in more cleaning services needed. There's also acid rains, which we said would peel the paint of buildings, which means we need to paint more. Concrete surfaces become pitted or have holes. We need to therefore renovate those. Metal structures become corroded, so corrosion is a thing. Because of the acid rain, and we now also need to renovate those more often. We also need to replace the damaged materials with good stuff that is durable, which is costly. Replace, air conditioner filters because now it's hotter. And then we also need regular painting of roads because of the acid rain. So just think acid rain, just think the pollution itself, what is it doing? There's damaged plants that we need to replace. Everything's replaced. Water reservoirs become polluted and we need to purify the water. So basically all those things are affected simultaneously. Alright, we have reached the end of the video. Thank you so much for watching. Please watch the rest of the videos that we have uploaded already and subscribe to see more content coming up, and share with your friends, comment any questions you might have, and I will see you in the next video. Bye.